over a century, AGC has been an innovator in various industries. We've brought comfort to people's homes, entertainment into their lives, and we've been helping people to get from place to place faster and safer. We have brought communities together with our products. We offer a wide range of materials such as glass, electronics, chemicals, and ceramics. And operate in over 30 countries and regions with over 50,000 employees, working to provide essential products for day-to-day life. Our research and development team thrives to achieve a better society and standard of living. At any point in time, AGC has played a part in supporting society, providing unique materials and solutions. Our glass is used in buildings and vehicles around the world. Our chemicals business offers a wide range from daily products such as baking soda to materials used for iconic buildings around the globe. Furthermore, providing solutions to advanced medical care and expected food shortage issues. Our display glass enables clearer images. By utilizing a wide range of technology, AGC contributes to the development of the electronics industry. By providing unique materials and solutions, AGC is always around you, supporting people's lives anywhere in the world. AGC, an everyday essential part of our world.
Hello, everyone. It's my absolute pleasure to be here today to contribute an opening presentation on the World Green Building Council's Circularity Accelerator program as part of the Asia Pacific Festival, our Resources and Circularity Month, taking place in August 2022. My name is Katrina Brady. I'm Director of Strategy and Development at the World Green Building Council, based in London in the United Kingdom, and thank you so much for being with us today. In my presentation today, I'm going to give an overview of the work of World GBC's Circularity Accelerator global programme, beginning with a few words on strategy. As I'm sure many of you are familiar with, the World Green Building Council Global Network represents an action network of 70 green building councils around the world, which we also have divided up into 5 regional networks. Our global membership represents a collective group of organisations who are members of the Green Building Councils, representing around 36,000 organisations around the world dedicated to sustainability in the built environment. Our strategy is simple. We have 3 thematic impact areas, which are aligned to the targets and indicators of the Sustainable Development Goals. We have a global programme that speaks to each one of these strategic impact areas. There is the Advancing Net Zero programme, which speaks to climate action, Better Places for People, which speaks to health and well-being, and today we are of course focusing on resource efficiency in the circular economy, which we are hosting in the Circularity Accelerator global programme, which launched only a few months ago. The North Star, or guiding goal for the movement that we have set for our work on resources and circularity, is specifically aligned to the Sustainable Development Goals around SDG 8, 12, and 15, predominantly around SDG 12, which is responsible consumption and production. Our overall vision is that we're aspiring to create a built environment that facilitates the regeneration of resources and natural systems whilst providing socio-economic benefit through a circular economy. By 2030, we have a sub-target within that. We're looking to be achieving zero waste to landfill targets on an international scale and working towards a built environment with net zero whole life resource depletion. And that's part of our 2050 target as well. And these global goals are what we are aspiring to target through the work of our global membership and the program that we have set up to aid them. Our internal strategy is a little more specific, and I won't go through all the details on this here, but what you can see down the left-hand side of my screen are the 7 ways in which we're working with the green building councils around the world to make that change and to work towards the targets of our North Star goals. We collaborate with leading organizations around the world. We want to ensure alignment and cohesion with other work that's happening in the circular economy space. We are very strong in our global advocacy as well as regional policy and regulation guidance, supporting the policies that require efficient use of resources in the circular economy. Additionally, we endorse the role of rating tools and certifications on a national and international level. Communication and education of the wider industry and our members is a key priority for us and something we will support the Green Building Councils with doing so on a national level. And innovation and investments, particularly the way we can mobilize green finance to implement a circular economy, are 2 other areas as well we're committed to exploring through the strategy of this work. So let me begin by sharing a little bit of work that's already happened in this space. First of all, there is fantastic leadership within the World Green Building Council network already on the circular economy, on regeneration of nature, nature-based solutions, biodiversity, and I would encourage you to reach out to your local Green Building Council to find out what they are doing at a national or regional level. On screen are just a few examples from some of the many green building councils who have work in this space, all of which is publicly available. And for example, you can see the Green Building of Australia's Insights into Circular Economy training programme in the bottom left of the screen. This slide is more specific to a European audience, but I do think it's interesting to share in terms of its relevance on the international political agenda that the World Green Building Council team has taken a very active role in advocacy as part of the EU Commission's platform on sustainable finance. One of our colleagues, our Director of Europe, Stephen Richardson, was leading the team in the EU taxonomy consultation who were coming up with the criteria for the circular economy section of the EU taxonomy, and subsequently we're also developing a policy whole life carbon roadmap through the Building Life programme. All of this information is available on the World Green Building Council website, and I think it's particularly been relevant for us as global programme participants to be able to see the leadership and action that's happening in some regions of the world and explore the ways in which it can be scaled and replicated in other geographies. We have also been undertaking internal market research, and this slide you can see on screen was from actually an internal session that we ran last year around the barriers for the circular economy, where you will see that lack of financial incentives came out as the biggest barrier for achieving a circular economy in the built environment with the focus group that we were discussing. The numbers do add up to higher than 100. That's because people were able to pick more than one option each. But this certainly highlighted the wide range of challenges across the system that we're going to have to face to implement a circular economy, whether that's on a local level, regional, national, or ultimately global. So that takes me to what we are doing this year and how we would love to invite you to get involved and participate alongside us in this work as we aspire to create a more circular built environment. Our Circularity Accelerator Global Programme launched in May of this year, and you can find more information about that on the Circularity Accelerator webpage that you can hopefully see on my screen. We are developing a range of branding and communication asset materials, which will also be on the website, that are free and available for people and organizations to use. So please do feel free to make use of those materials as they're launched throughout this year. It's also my pleasure to be able to introduce the Global Steering Committee and partners of the programme. We are delighted to work with close to 20 green building councils currently, and it's a very international range from the Asia Pacific network. We have, for example, the Green Building Council of Australia, Hong Kong GBC, New Zealand, Singapore, and I'm sure we will be welcoming many more in due course. And you can also see the expert partners, the industry leaders who we have the pleasure of working with, from Brightwork Sustainability, Ramble, Foster and Partners, VinZero, CBRE, and WSP, many of whom you will be hearing from during this festival. Now, a deliverable that I'm excited to share some information about is our proposed market research report. And this is going to be a commentary and an analysis of the state of the work that the real estate sector has been doing globally in terms of implementing a circular economy. We want to be able to help overcome some of the confusion and the misalignment in this sector and with the various terms and the terminology around the circular economy. So through this publication, we're going to be amalgamating the work of global leaders, both the green building councils around the world, as well as our partners, but also other NGOs in this space who are doing fantastic work, including the World Business Council for Sustainable Development, the Ellen MacArthur Foundation, the World Resources Institute, the World Economic Forum. There's many, many more. And we want to make sure that we are publishing in one place a resource list that allows people to understand the different calls, the different scopes, definitions that all of these organizations are publishing around the circular economy, so that we can understand where there are these areas of alignment and where we need to do further work. We're specifically going to focus on sustainable construction materials, everything from how we can make heavy materials such as steel more efficient, lower the embodied carbon of that, increase the circularity potential, through to thinking about things like bio-based materials and how we can create a market for secondary materials. The second big section will be on design and retrofit, how we can ensure our buildings are designed for disassembly, how we can promote adaptability, how we can retrofit buildings to become more circular, and what are the requirements, the design considerations that we need for our new and existing buildings to be able to take our existing building stock and our cities of the future and ensure they can contribute to a circular built environment. The third section will be about the regeneration of nature, and this topic's incredibly exciting. The restoration of natural systems was part of the language in our North Star goal that I presented earlier. And here we will be showing what's happening across our global network and the wider world in terms of nature-based solutions, again, the use of bio-based materials, in terms of restoration of ecosystem services and other natural systems, and how we can help to bring the green back into the urban environment as part of our circularity efforts. So that report we are aiming to launch at the end of this year. So please do keep an eye on our social media channels and on our website for further updates on that. Into next year, we will initiate a network consultation where we will engage the wider industry in the development of a framework of principles that builds on our research report that will speak not only to the global advocacy movement, but also to local markets, aligning what we have in terms of leadership already at national and regional scale. And we're also committed to providing training and communication materials for green building councils around the world. So please do get in touch and we will be working with the green building councils as well to ensure that we're making these high quality materials available to be disseminated across the network. You can also reach out to any of our partners at any time who are all experts in this space, as you will hear in the follow-up presentations throughout this festival, and they will certainly be happy to share more about the work that they're doing on this topic as well. And so with that, it's my pleasure now to hand over to the following speakers, follow-on speakers during today's session. And thank you very much for having me today. If you have any specific questions, please do not hesitate to reach out to myself or any of the team directly, and we will look forward to working with you and being in touch again in the future. Thank you very much, and I hope you enjoy the festival celebrations.
Good afternoon, everyone. I'm Susan from AGC Asia Pacific Private Limited Cross-Functional Project Division. It is my pleasure to represent AGC to speak to you today on the efforts AGC have taken to achieve the realization of a sustainable global environment. Without further ado, let us get started. Sustainability is in the forefront and at the focus of corporate strategy worldwide. In AGC, environment is one of the 4 shared values, others being innovation and operational excellence, diversity, and integrity. Our mission is to develop advanced materials and solutions to improve people's lives globally. Taking a brief walk through our history, since 1907 till date, AGC have provided innovative materials and solutions in line with the changes of time. We have since evolved from Asahi Glass Company, which started out as a flat glass business, to AGC Group, where we have since expanded our businesses to include electronics, chemicals, ceramics, and many more. To realize our Vision 2030, AGC Group aims to create a sustainable economic and social value by transforming our business portfolio. In addition to meet our financial targets, we also want to achieve a balance between business growth and realization of a sustainable society. We will strive to achieve the sustainability mission in all our business activities and contribute to the resolution of these 5 key social issues. With the environment being an integral of the company's shared values, AGC continuously and effectively utilize resources and develop products to the realization of a sustainable global environment. Climate change and effective use of resources are 2 of the risks identified. AGC solutions and products are designed to address these issues. This will be explained shortly in today's explanation. Such efforts then contribute to the United Nations Sustainable Development Goals. Likewise to the earlier slide, here is a continuation of the list of healthy cooperation activities that create social value, which are related to the identified Sustainable Development Goals. The AGC Group aims to achieve net zero carbon emission by 2050 and pledge to reduce our total CO2 emission through energy saving and energy creating products. Specifically, a 30% reduction in greenhouse gases emission by 2030 and a 50% reduction in greenhouse gases emission per unit of sales to realize a sustainable global environment. Let us take a look at what are the steps we have taken thus far to achieve this target. We are committed to prioritizing environmental impact and sustainability in the manufacturing of our products. AGC became the first European glass maker to obtain cradle-to-cradle certification for its float glass and magnetron coated glass in 2010. Since then, we have had 8 product ranges that are cradle-to-cradle accredited and have successfully renewed and maintained the relevant certification as well, ensuring our relevance to the ever-changing standards. Notwithstanding that, AGC Glass Europe was also awarded the silver certification in the water stewardship category of the Cradle-to-Cradle Certified Program in 2015. The depletion of natural resources is a critical issue at hand, and it is essential that corporations are doing their best to reduce the consumption of natural resources. And here at AGC, we reduce our utilization of natural resources by as far as is technically possible. In the glass manufacturing process, we use glass cullets as a substitute for raw materials such as silica sand and refuse glass from urban centers for reuse as a raw material as much as possible. The ratio of recycled material present in products are indicated in compliance to the ISO 14021 standard. AGC Group had successfully reduced 53% more CO2 emissions in the year of 2020 as compared to 2019 through the usage of glass cullet. Calcium fluoride is a natural resource used as a raw material to produce various fluorinated products. But the deposits and producing countries are limited. Most Japanese enterprises, including AGC Group, largely depends on imports from China. Another key effort that AGC Group has undertaken is to recover used fluorocarbon products from customers and recycle them at AGC Shiba Plant, Japan. A byproduct generated from the destruction and manufacturing process is calcium fluoride. We also recover calcium fluoride in the hydrofluoric acid, which is used in the wastewater treatment processes by customers. In recognition of these activities, AGC received the Minister of Economy, Trade and Industry Award in the Awards for Resources Recirculation Technologies and System in 2014 in Japan. In year 2019, fluorocarbons equivalent to approximately 1.34 million tons of CO2 were recovered. In the past, the used refractories would be buried as waste. However, as part of AGC key efforts to reduce the consumption of natural resources, refractories are now reused as aggregate raw material for monolithic refractories by removing impurities from refractories soon to be disposed of. A granular material is recovered after crushing and pulverizing. AGC Publico promotes initiatives for recycling refractories such as bricks and other materials that are used in blast furnaces and other applications for reuse as raw material for refractories. By using them as raw material, it contributes towards waste reduction. In response to the need to balance realizing low global warming potential, whereas maintaining the energy consumption, energy conservation performance of refrigerants for air conditioners, AGC has created ammonia products that contribute to the environment. This ammonia is a next-generation fluorinated, non-flammable refrigerant and non-flammable solvent with low environmental impact while keeping high performance effect. Ammonia series received the Minister of the Environment Award at the Japan Association for Chemical Innovation Green and Sustainable Chemistry Awards in 2020. Uniporous, on the other hand, is a biological filter that is made from sea urchin shells. 85% of shells go to waste yearly due to the challenge and time required during processing. We aim to resolve these social issues with the cooperation from the Fisheries Research Departments of the Hokkaido Research Organization. Uniporous was recognized for its high level of recyclability as a Hokkaido Certified Recycle product in 2019. In bid to reduce freshwater consumption, the AGC Group is promoting wastewater recycling alongside a reduction in clean water usage and wastewater through water filtration. As part of our efforts to prevent water pollution, we have established wastewater control targets that are tailored to the characteristics of each site. These are the results of our efforts to utilize water resources efficiently. 85% of water used for cleaning and cooling in production process are seawater that are used for indirect cooling. The amount of freshwater recycled or cascaded in the production process is equivalent to approximately 16 times the amount of freshwater used. AGC Group has long been proactively carrying out a wide range of energy-related activities, and one of which is the photovoltaic power generation projects to realize energy saving and creation at AGC plant and office building. In 2020, 5.5 million kilowatt-hour of power was generated by the solar panels installed in Europe, and 25,000 kilowatt-hour of power was generated by the solar panels installed in Japan. AGC's subsidiary has also installed biomass boiler to provide steam to its plant's production line. These activities contribute to the AGC Group's efforts in utilizing renewable energy worldwide. In summary, as part of AGC's commitment to creating a sustainable future, we have outlined the fundamental approaches as follows. Number one, to establish a long-term goals of achieving net zero greenhouse gas emission by 2050. Number two, promote zero landfill and continue steady progress to reduce the amount of waste generated. Number three, expand the product promotion of renewable energy at business site of group companies. Number four, proactively promote energy conservation in manufacturing process. Number five, introduce cogeneration system to maximize the use of energy. And lastly, provide products and solutions that contributes to energy savings and generation, also contributing to the mitigation of climate change as an overall. And that brings us to the end. Thank you so much for interest and attention. We hope it was insightful. If anyone has any questions, please feel free to contact me and I will do my best to assist.
Good day, everyone. Good morning, good afternoon, good evening, depending on where you're tuning in from. This is Alvin from the Singapore Green Building Council. I'd like to thank AGC for inviting SGBC to share at this webinar. And today I'll be talking about perspectives from Singapore with regards to circularity and resources. I'll talk about circularity first because there are two interesting case studies from Singapore that I'd like to share with you all before we talk about resources. Right? Okay, so let's start the presentation. And first we have the table of contents. We'll talk a little bit about circular economy, what the terms are, what its purposes are, before we go deeper into new water, the water situation in Singapore. And then for the building and construction industry, we have the demolition protocol and the use of recycled concrete aggregates in Singapore. And I'll round it off with environmental product declarations for the resources side. So let's start with circularity. What is circularity? And circularity is basically moving from a linear economy model to a circular economy one. Right, so linear means a single line. We start from taking raw materials from Earth, making them into products and materials that we use in our day-to-day lives, make our lives more convenient. And when the product has outlived itself, it's reached the end of its life, we then dispose it as a waste material or waste product. So in this model, you can see that the resources are extracted and designed for single-use life cycles, and we discard them as waste after use. The value for this is the value is created by producing and selling as many quantities as possible. So here you can imagine things like mobile phones that are very infamous, right, for being part of a product obsolescence. Every few years you have to upgrade to the latest model. So these are all signatures of a linear economy model. But let's move on and discuss what it is about a circular economy model. So circular economy changes the way value is perceived. The focus shifts towards value retention and material longevity across multiple life cycles. How do we do this? We do this by using the waste materials and reintroducing it into the manufacturing process. So this actually closes the cycle of raw materials and extends the lifespan of materials. So I like this picture on the right because it paints a more realistic picture. After manufacturing and after the use stage, any materials that can be recycled will be reintroduced back to the manufacturing stage. But this picture realistically paints that there is a certain amount of waste that has to exit the cycle. There is a certain amount of fresh raw materials and raw resources that have to be entered into the cycle. So the big question for us is actually, how do we maximize the amount that's being recycled? How do we minimize the amount of waste exiting the cycle? And how do we minimize the amount of fresh resources entering the cycle? So this is the big challenge of circular economy. And it's all to address these purposes. Resource scarcity, keeping resources in use, giving them multiple lifespans, and using it more efficiently. In doing so, we then reduce waste and we reduce the environmental impacts. So now that I've discussed this a little bit, let us talk about the first case study on new water. So in the water sector, Singapore has four national taps, four sources of water. If you look at the icons on the left, these are our local catchment, which is about 17 reservoirs. We also import water from Malaysia, our closest neighbor to the north. We also have developed capabilities in new water and desalinated water. So new water and desalinated water, they actually both fit the model of a circular economy. I will explain why I've decided to talk about new water more later on. But let's talk about what it is first. So New Water is actually launched since 2003 for any used water from households and industries. This water is actually reclaimed and captured before being purified through a three-step process. And then the purified water at the end of it will be reintroduced into Singapore's water supply. So this caused quite a stir when it was first launched. I'll share with you. Because used water also refers to human excretion or urine, right? So it was a big item of debate. Very much of the population was skeptical, some were fearful, some were disgusted, but we have gone through many stringent tests. It is actually of the highest purity. So how do we show this is that during the application in industrial production of wafer fabs and all that, actually a higher purity of water is required than drinking potable water. So the end result, new water at the end of this three-step process is actually of the highest grade that is being used in these high-end production facilities. It is also used in commercial buildings, for example, cooling towers and refrigerants and things like that. And even in dry spells, dry periods, new water is used to be introduced into our reservoir where it's mixed with the fresh water. And this will then be tapped into our homes as our drinking water actually. So you can very begin to see that new water is a process of using used water and reintroducing it into usable water. Very circular economy of it. And how important is it? So today, the daily use of Singapore's water is about 430 million gallons per day, right? And new water can account to up to 40% of that demand. And desalinated water about another 25%. 50% of it comes from imported water, like I was sharing. This is through our agreement with Malaysia. And the balance of it comes from our local catchment. So for us, this is a very strategic national resource. We are putting up capabilities to further refine and improve the new water and desalination processes. So you can see by 2060, we target for new water to meet 55% of water demands and desalinated water to meet 30% of water demands. So 2060 is a very critical date because the water agreement we have in Malaysia actually ends in 2061. And for those who are more, politically inclined, following the news in our region, historically, this has been a very, let's say, tricky situation between Singapore and Malaysia. So you can see, apart from meeting circular economy goals, this item is also one of national importance to talk about self-reliance and ensuring that we have our own form of water supplies. So you can see that new water improvement is like about 15 percentage points versus desalinated water 5 percentage points. And the reason for this, I think, is what we discussed earlier, where circular economy, we talk about how to minimize the amount of fresh resources being introduced. So comparing against a baseline of treating rainwater from our local catchments, the energy used for desalinated water is actually about 17 times of that. In comparison, new water is only about 5 to 6 times of that. So this is also another key reason why a new water is a better case study. We not only address the circularity aspect of it, we also address the use of fresh resources entering the cycle. So I hope that paints a nice picture for the water aspect. Let's move on to case study 2, recycled concrete aggregates. So recycled concrete aggregates are raw materials that are being used in the production of cementitious and concrete products, right? So you have your OPC, ordinary Portland cement, you mix in concrete aggregates, you make in concrete fines and other things in order to produce concrete. And here we have recycled concrete aggregates, which means that we don't need to use as much raw aggregates or virgin aggregates. And before we jump straight into it, let's talk a little bit about the demolition protocol in Singapore. So the demolition protocol is part of the Singapore Standard 557, 2010 edition, Code of Practice for Demolition. It's been around since 2002 under a different name, but the key items here are the pre-demolition audit, the sequential demolition, and the site waste management. So when a building is identified for demolition, we actually have to conduct an audit or inventory stock taking in order to identify what materials are reusable, what materials are recoverable, how much of it has been contaminated, and what has no choice but to be disposed of. So these materials include things like pipes, wiring, concrete, bricks, so on and so forth. Right. So after we've done this audit and stock taking, we can then do the execution aspect, the demolition proper itself. And in this stage, building material is dismantled one building material type at a time. And they are carefully dismantled and salvaged for recycling and reuse. So why we do it one at a time is to ensure that we can properly sort it out, and we can ensure that these materials are not contaminated by other materials on site. So by sorting it out, this also falls in part of our site waste management. We have the on-site temporary storage of these various materials so we can appropriately deal with them. Some will be marked for disposal, some will be marked for transport to the appropriate treatment facilities for reuse, recycling, so on and so forth. And this actually forms the backdrop of how we talk about recycled concrete aggregates. So you can imagine, in terms of the concrete debris that comes from all our demolished buildings, these can then be collected, compiled, and then transported to treatment facilities. Over here at treatment facilities, they are broken down through things like excavators and draw breakers. And at the end of this breakdown process, we can screen, segregate, and come up with aggregates and fines. So like mentioned, these aggregates and fines are actually raw materials in the production of concrete and cementitious products. Initially, when we first derive such material, we've used them in roads and other non-structural concrete products in the applications whereby structurally it's not as significant. But we didn't stop there. We took it one step further. We thought to ourselves, how can we incorporate RCA into, how can we make better use of it, maximize the efficiency of this raw material. And all that thinking and questioning led up to the Samwall Eco-Green building in 2010. So Samwall is a local company. They are builders. They are involved in construction. And what they did was they led a research project in collaboration with public agencies and institutes of higher learning. So that is the Ministry of National Development, and the Building and Construction Authority of Singapore, and our Nanyang Technological University. So multiple stakeholders was involved in this project, this research project, and what they focused on was to evaluate the performance of concrete that contains recycled concrete aggregates. So one of the key findings is that if you compare traditional concrete versus a concrete that contains RCA, there actually is an insignificant amount of differences. When they look at the structural monitoring results as well, the deformations that the RCA concrete shows fall within theoretical deformations. So these were all very good news and findings, and the study concluded that RCA concrete can be designed for structural applications beyond the roads and the non-structural components or products that we've talked about before. So from this point, Samwall, they brought to reality the findings of the study. The Eco-Green building is constructed using RCA concrete. So any of the cementitious or concrete elements found in this building, these are actually not your typical concrete. These are your RCA concrete instead. And in certain cases, the aggregates used would be up to 100% recycled concrete aggregates. So zero use of fresh virgin concrete in those aggregates in those cases. So it's a very good case study. Up to today, it still receives delegations and visits from ministries, from political office holders, and so on and so forth. It is a very successful case study project here. So I hope this has painted a nice picture for Singapore's application of circularity principles in the water and the use of RCA. Now let me move on to resources aspect of this webinar series and the use of environmental product declarations. So I started with circularity first, is because although circularity is a very good thing, it is the thing of the future, we need to bear in mind that unlike water, unlike RCA, not all products or product categories can make that jump to circular economy model so rapidly or so quickly, right? So we're stuck with a lot of products that's still in the linear economy model. The thing is, we can't, don't care about them. We can't leave them aside. We have to ask, how can we improve this, right? So compounding on this question, we also talk about carbon emissions of the building sector. Globally, buildings account for 39% of global carbon emissions, and it is a building challenge, a mega trend, carbon mega trend, right? And we've talked about buildings, we can further break them down into embodied or upfront carbon versus operational carbon. Now, if we talk about operational carbon, you can see that the green bars, they are decreasing over time. That is showing the improvement of technology, the shift towards energy efficient building products, and the shift towards renewable sources such as solar energy. These are all factors that can improve the operational carbon performance of buildings over time. Even locally as well, Singapore is doing a lot from a government standpoint, a lot of schemes, a lot of initiatives, and even putting into regulation the need for higher energy efficiency of buildings. In comparison, the upfront carbon is a little bit overlooked. You can see from the graph, upfront carbon is locked in upon building completion at year 0 of the building lifespan. It cannot be improved over time. And if we do not address it early on, it will simply be stuck there like a black mark on your report card for however long however long the building may stand, right? So this is where EPDs or environmental product declarations come into the picture. EPDs are like healthy food labels that report on the sustainability impacts of products. So instead of things like fat amount, sugar amount, or carbohydrate protein amount, EPDs tell us about the environmental impacts of products. Acidification, ozone impacts, GWP, so on and so forth. And what we want to address in terms of the embodied carbon side is these 3 stages, which is also referred to as cradle to gate, the extraction of raw materials, the transport to manufacturing plant, and the manufacturing process itself. So EPDs are able to give us a deeper picture of the carbon emissions associated to these 3 stages of products. So over here, we have this chart on the right. This is a typical chart that you will see in an EPD report. Over here, over at the bottom half of that image, I've highlighted that one row on GWP. GWP stands for global warming potential and is measured in kg CO2e equivalent per unit of material, right? So think about that in terms of currency. We talk about USD where currencies can be, monetary value can be compared. GWP or kg CO2e equivalent is kg CO2e is the currency to compare the carbon footprint of products. So in this case, if you have, let's say, maybe 2 carpet products, if you take a look at the GWP of each of them, you can actually use it to make a comparison to say which of these carpets have a lower carbon impact. And you can make a selection from there. So going back to the analogy of healthy food labels, if in that category you are a dietitian or a chef, you can actually choose your ingredients that you want to make a meal out of. Similar to that, as a project team, architect, ESD designer, you can choose the materials that go into your building project that have the lowest amount of carbon impact. And at the same time, suppliers, when they review their products and maybe compare it against competitors, then they can actually find out where is the room for improvement of their processes and their product design. So this is a very quick snapshot of environmental product declaration. I can go into a lot more detail on that. SGBC is advocating for the use of EPD locally, but due to time constraint, this is all I have for today's sharing. I'll leave us with a nice picture of a less seen angle of our CBD area, highlighting a bit of the rustic feel from the shophouses and the modern skyscrapers. So for those who have visited Singapore before, this is what we look like. I hope this serves to stoke a bit of memories. And those who have not visited, I hope you do join us someday and take in this breathtaking view. Yeah, thank you very much and have a great webinar ahead.
Hi, this is Aoi from Shimizu Corporation. I'm Deputy General Manager in Singapore HQ. I'd like to thank for giving me an opportunity for this presentation regarding Shimizu Beyond Zero 2050. First of all, I'd like to introduce about Shimizu Corporation. Shimizu's main business is building construction and civil engineering, having branches in 20 countries. Shimizu was founded in 1804, 218 years ago. As of 2020, we are the 26th largest construction company in the world. Shimizu Beyond Zero 2050 is our target to create a sustainable society, providing positive environmental value to customers and societies that extend beyond zero negative impact from the company's own business activities. Shimizu Group will create a wealth of environmental value through innovation approach from the three perspectives of zero carbon society, resource recycling society, and society that coexists harmoniously with nature. We are not questioning ourselves if we can achieve or not, but we are committing ourselves to achieve net zero emission, a final waste zero, and zero negative impact on the environment by 2050. Zero carbon society. It is our responsibility to eliminate CO2 emissions by 2050. Since 2005, we have set CO2 reduction target to tackle middle-term and long-term effect. As a design and build contractor, we contribute to design buildings with this aim and drive the society towards zero carbon with technological innovation and generating power from renewable energy. Society that coexists harmoniously with nature. The construction industry tends to be perceived as a negative impact on the natural environment such as land development and deforestation. By 2050, we aim to quantify the impact and accomplish zero negative impact. To achieve this, we will keep a rich environment that has a positive impact on biodiversity for future generations by introducing green infrastructure, utilizing diverse capability of nature in various ways. Resource recycling society. We aim to achieve a zero final waste generated by our own business activities by 2050, including construction and office waste. We continue to work on recycling society resources through the entire construction life cycle, from material procurement to dismantling. Today, I'd like to introduce actual application of environmentally friendly temporary construction material and resource recycling and waste reduction. Environmentally friendly temporary construction material, which I would like to introduce, is Kamiwaza. Kamiwaza is a solution for temporary construction materials at civil engineering site that uses paper materials made from waste paper and pulps. It was jointly developed with Oji Holding Corporation. The main product of Kamiwaza is Hyper Ace. This product has advantages of easy transport, flexible shapes, space saving, environmentally friendly, high weather resistance, and high rigidity and strength. This is an example of actual application of HyperAce. In tunnel construction, we install a windbreak facility called windgate to prevent outside air from rapid entering. The conventional windgate is made by inflating nylon balloons, which requires a lot of sequence of work, man-hours, and cost. Thus, we adopted HyperAce, which has a required strength and it's lightweight. Work efficiency has been improved by pre-cutting and crisp processing. With simple mechanism that just fit the HyperAce with a L-shaped cut for hooking on the scaffolding. It can be fixed easily and securely. In addition, since the shape and dimension of each tunnel are different, the conventional balloon need to be disposed, while the HyperAce is recyclable, and the shape can be easily adjusted. Since HyperAce is a carbon board material with a 3-layer structure, which includes an air layer inside, it has a high sound insulation performance. Hydraulic pile hammer generates large noise, and even a soundproof cover is installed. Sufficient effect has not been obtained due to the sound leak from the opening. Thus, we devised an opening closing cover that takes advantage of the sound insulation and the workability of HyperAce. It is designed to minimize the gap between HyperAce and outer soundproof cover. Measuring the noise at the position 30 meters away from the hydraulic pile hammer, the noise was reduced by about 5 dB. In particular, in the frequency range of 1 to 4 kHz, a maximum reduction effect was 9 dB. On job site, we plan and promote 4R activities. 4R consists of the initial of 4 words, which are refuse, reduce, reuse, and recycle. For example, requesting product delivery with packageless method, pre-cut at the factory, bring waste material to a manufacturer for recycling products. There's one project in Japan promoting high recycling construction. With a large-scale renovation work of existing facility in Tokyo Big Site, existing exhibition hall would be unavailable to use for 10 years. Thus, a temporary exhibition facility was planned to set up a system in which events can be held continuously. We were selected as a design and build contractor after the open tender with a comprehensive evaluation. As the building is to be demolished in about 10 years, we propose minimize the environmental impact during the construction and demolition, and eco-friendly building with a high recycle rate. Here is the project outline. Location, Tokyo, Japan. Construction schedule was 2015 November 12 until 2016 October 9. Building use was exhibition hall. Total floor area, 19,905 square meter. Building height, 16.4 meter. Two-story building, superstructure by steel structure. Foundation, pile foundation. And metal roof with external wall of ALC panel. Total construction period was 11 months. We constructed roof and external wall in advance prior to the slab casting and subsequent finishing and M&E works, so that noise and dust could be minimized. By following the reverse sequence, similar effect could be expected during the demolition work in future. This rotary press-in steel pipe pile is a method in which steel pipes are pressed in while rotating, and they can be easily pulled out by rotating them in the reverse direction when dismantling in future. This is an environmentally friendly method that minimizes noise and vibration and generate nomad. The use of steel pipe pile also allows us to reuse and recycle 100% of steel pipes after they have been pulled out. The pearl head ring socket construction method is our unique patented construction method. This method surrounds steel pipe pile and steel column base with ring sockets, filling the gap with concrete to integrate them. Stress at the bottom of the column are carried by the pile so that ground beams can be omitted. As a result, the volume of excavation soil and the concrete can be reduced, resulting in reduction of CO2 and waste. 2,650 tons of steel frame of the wall are designed as a hanging structure to cope with the ground settlement. 8,760 square meters of external wall are formed with ALC panel and metal cladding. 17,000 square meters of roof is double layer of metal roof with glass wool sandwiched in between. All the materials selected for the superstructure is recyclable, while satisfying the strength and resistance of building standard. Structure was designed as simple as possible to ease dismantling work. We encourage suppliers to deliver products with cage trolley to reduce the packing. Pipes and M&E equipment are prefabricated together with steel frame in a factory to deliver with minimum package. By simplifying packaging, we are able to reduce CO2 emission and industrial waste. Set up eco station to ensure separation and the management of industrial waste. 10 types of sorting box were set, and we have achieved recycling rate of 93.4% with a total volume of 14.6 kg per square meter. To improve workers' awareness of sorting to reduce mixed waste. Display QR code in case confusion about sorting. This system is utilized when unknown industrial material items was there. Take a photo of unknown items and send it via QR code for verification. Today, I only could introduce a part of our activities. From our activity, SHIMS aim to contribute for positive world that achieve beyond zero. That is what we want to build for people living now and the children who have a right to thrive in future. That is all for my presentation. Thank you very much.
Hi everyone, we are Lina and Omar from Green A Consultants, and we are here today to talk to you about circularity from the perspective of green building certifications. We hope you enjoy this presentation.
Yeah, today we are talking about first an introduction, what is circularity, the overall perspective, then the implications on the built industry or on the city design. Then we will walk you through the green building certification and how each certification address circularity. At the end, we will be giving you like what we call our circularity recipe.
So circularity is a term often heard in the field of sustainability, and in traditional whole life cycle of products actually enter a linear economy model where raw materials are extracted, manufactured, processed, distributed, and then used by the end consumer, after which it is then thrown away and incinerated. And this is a waste because most products are still in good conditions or are only used for a short period of time. Fortunately, circularity is now more incorporated in the thought process, where reduction by design, reuse, refurbish, repair, repurposing are increasingly encouraged, helping to extend the lifespan of a product.
So applying this to a city scale or on our city, how our cities work. So we call this urban metabolism. Why? Because we perceive cities as a living organism or a living body or a living being. So with inputs of resources, these are then used to sustain the living conditions of society for economy, waste, water, and energy flow. And so we can here see like two very important flows of materials as well as energy. Then our own input, which is reduce, reuse, and recycle. So to minimize waste going to the outputs, we will be looking at first pollutants, secondly waste. So this is just to say that, yeah, in most of the cases, practically, we don't see recycling happening or we don't see this backflows happening as such. But for now, we just want to focus on the impact of this pollution and waste.
And if circularity is actually not adopted in the built environment and buildings, there will be strain on environment and natural resources, strain on landfill and government spending as well. And there will be unhealthy levels of carbon emissions, which is already happening, causing more pollution and waste. So how does this actually apply to a building's life cycle? In the typical life cycle of a building, we actually see 5 main stages. First is the design and planning. Second, construction of the building. The third one, a building in operation, meaning when it's already living a building. And the fourth one, addition and alteration, where they go through retrofitting after like maybe 20, 30 years, and demolition and disposal at the end of their whole life cycle. I do see that we try to address circularity in terms of energy, water, waste in the entire life cycle of building. So in design and planning, where there are project teams that actually set the boundaries on embodied carbon, and increasingly there are also more and more guidelines on maintenance to actually prolong the lifespan of the building. Secondly, under the construction of building, we see that there are actually thresholds being set to actually contain the amount of embodied carbon in structures, foundations, floorings, and also the encouraging of use of low carbon materials such as certified products. And in the building, in the operation of building, we see energy efficiency being improved through HVAC systems, encouraging circular water management, having waste management for recycling, disposal, and also this thing called IoT for climate, where sensors and monitoring are used to actually further mitigate carbon. In the addition and alteration stage, of course, there will be new technologies being added in. And also in the last stage, demolition and disposal, we see that, for example, having demolition protocols to reduce the waste during demolition, and also having ensuring recycling happening at that stage. So all this, I see that we're actually trying to address circularity in the life cycle of a building.
It is the typical life cycle where actually in each of those stages there are already standards and certifications being or guidelines being used to guideline the process itself or to ensure the quality itself. But I believe here our main question is, if we are trying to achieve circularity or to close this circle, the question is there one certification or one rating system that can address all those elements, or all those stages? As we see it, actually the answer is no. So just to start with, most of the certifications that we have, they will be focusing on those 3 stages. So they will be guiding the design stage, guiding the building operation, like energy, waste, or water consumption during operation. There are also for sure building standards that will be guiding the process of retrofitting, like standards for major renovation of buildings, that will really tell you how to achieve sustainability. But we notice from our experience or from our contact with those green building standards that the demolition stage as well as the construction stage is somehow missing from the standards. And it's not that it's missing because it's missed out, just because it is the reason is that, especially for construction, the first thing is very difficult to quantify the impact of construction process, and secondly, it's even more challenging to set a threshold of the construction process emissions or construction process impact.
But I see more and more construction companies or organizations coming to tell us that they identify this problem, and they're trying to also start measuring and also tracking as well.
I think important also to be reporting their impact at the same time. So in the next section, we will be talking about the major certifications that maybe we are all using and how each certification addresses circularity in the built environment.
So in this presentation deck, we'll be going through 5 different certifications: PCA Green Mark, LEED, True, ILFI, as well as H. So under Green Mark 2021, which is one of the latest standard under this scheme, there are actually 5 main categories: resilience, health and well-being, whole life carbon, maintainability, intelligence. Energy efficiency is actually a prerequisite. So under this standard, right, we see that whole life carbon and maintainability actually focus on the not just the tracking and recording, but they also look at how to actually prolong the life cycle and lifespan of building. And how this is being done is that in the whole life carbon section, they look at how to actually measure the embodied carbon in terms of materials during construction and fit out. And for maintainability, it's like a guideline for you to actually design a building such that it's easy to maintain in the long run.
The next standard will be the USGBC LEED. I believe most of us might be familiar with this scorecard or how we are scoring with LEED, but my purpose here is to highlight where exactly LEED can talk or can address circularity in the built environment. So we see in some only of the credits that circularity is really being addressed. For example, rainwater management. This is to contain the rainwater on site and avoid runoff from the construction sites. For sure, energy credits by LEED, either through, the first one is through reduction of our energy, which means reducing our reducing our operational carbon, generating renewable energy on site, as well as purchasing or offsetting carbon through buying RECs. So this is a huge impact on circularity when it comes to carbon. The second section will be all the material related requirements. So LEED basically have a set of requirements, including the building life cycle impact reduction, where the building life cycle is simulated and the impact is quantified, and then scoring happens accordingly. So mainly LEED covers some under water, some under energy and carbon, and the rest under the materials, as well as also waste, which is covered under the construction waste here.
So under the True certification, which actually looks at the waste that is being produced during the companies or organization operating, one of the prerequisites is that they actually have to achieve 90% or greater overall diversion rate for the most recent 12 months. So in that aspect, this is one of the most important prerequisites for this company or organization to attain so-called zero waste. So the highest, of course, is 100%, and the lowest that is required is actually 90% and above.
The next building standard is EDGE. Maybe not everyone will be familiar with EDGE because EDGE was a standard developed by IFC to address sustainability in the developing countries, which is actually a major topic because most of the emissions, as we know, comes from developing countries, and also developing countries are expected to double population by 2050. So we find this standard really significant. And recently, this standard is targeting zero carbon and targeting also circularity in terms of carbon only by releasing this certificate, which is the zero carbon. So it works by, first, there's mandatory reduction in energy, water, and embodied energy by 20%. Then additional 20% energy savings. Then the rest should offset by renewable energy, in which then you can be awarded the zero carbon label. The final certification we are talking about today is the ILFI. We find ILFI is the most, I would say, most holistic as well as most stringent among all certifications. The reason is, in addition to having the zero targets in ILFI, the highest category of ILFI, which they call it actually the Living Building Challenge, and it's really a challenge, it's not a certification, it's a challenge to achieve. It requires positive water impact, not only zero, but it's positive water, positive carbon, as well as positive waste. Not only because it addresses this in buildings, but ILFI also addresses this in products as well as communities. So ILFI is so holistic that it has some labels also related to products, like the Living Product Challenge. And this also relates so much or relates so close to circularity, because circularity is not only to talk about the building, right? Mm-hmm. So the building has people and it's part of the community, and the building incorporates products. So if you give me this ecosystem which labels my products, labels my building, and labels my communities, then I'm really in a very good condition when it relates to circularity. I would say I'm on the correct path. So some of them also are only labels. So you don't need to comply with any threshold, for example, like declare and reveal. Those are only transparency labels, just to tell what is, for example, reveal will tell just what is the consumption of the building. Declare will tell what is the impact in terms of carbon and waste of this material without setting any threshold. So we are closing to the end, but this is our own recipe for circularity. So because we talked about different building standards, but we never really yet tell how to achieve circularity. So we would say, or we suggest, achieve circularity is through the 3 zeros: zero carbon, zero water, and zero waste. And as we can see, there is no one standard fall under, or there's no one standard that can achieve the 3, but each development or each building can pick their own certification based on their needs. But our target really, or our advice really, is to achieve the 3 zeros. Zero water and waste actually is comparatively straightforward, but in terms of carbon requirements, it's really different across those 3 standards, which I want to show in my next slide. So looking at zero carbon under those 3 different standards, ILFI actually has a threshold when it comes to operational carbon. It's also stringent when it comes to operational carbon offsets, meaning that whatever I cannot reduce, I cannot buy RECs. It's not allowed to buy RECs. I need really to purchase a new PV system, either on-site or off-site. It has a target for embodied carbon, as well as also target when I'm offsetting the rest of the embodied carbon that I cannot reduce here. So I'm here only reducing 10%, but then the rest I need to offset through only approved providers, and they're very stringent about this. When it comes to need, I would say it's somehow less stringent. The reduction is only 5% as a prerequisite. The rest I can offset through either PVs or through RECs. There is no threshold for embodied carbon. And my offset in terms of carbon can come from any LEED approved CER provider. Then when it comes to EDGE, that, as we just mentioned, EDGE is dedicated for developing countries. So the reduction in terms of energy, which we call operational carbon, is 20%. Then the rest I can offset either by PVs or RECs. There is no threshold for embodied carbon also. Then the final part is the embodied carbon offset. I can use my own, or I can purchase my own CERs. So to summarize, we see here that some certifications are more stringent than the others, which lead us to our next point, is that on top of the 3 zeros, actually sincerity is the most important ingredient of all.
Thank you, Omar, for sharing. Thank you everyone for listening to this presentation. Let's move towards circularity together.
Thank you.